thinking about design, our next customer, pleased to announce Philip Raw. He's Associate Vice President of Canon Design. Philip has spent most of his professional career at the intersection of architecture, academia, and technology. Philip has over 15 years of diverse architectural experience in a wide range of project types. As design leader, his responsibilities encompass establishing design direction, executing projects from concept to completion, while ensuring projects are completed within budget and schedule. Let's welcome Philip Raw to stage. Here's your clicker. Thank you.
As Jeff mentioned, my name is Philip Raw, and I am a senior designer and associate vice president for Canon Design. Canon Design is one of the largest architectural design and engineering firms in the world. We have over 17 offices throughout the world, having a presence globally as well as nationally within North America. One of the unique attributes of Canon Design is a service that we call SIFMO, Single Firm Multi-Office. What that means is that even though we have different offices throughout the world, we leverage the specialties and expertise of individuals and groups and bring them together to one place and provide a single service for the project. With this attitude and with this service, we are successful in providing excellent designs and approaches to innovative ideas. And one of the reasons why we're successful with this is we're using HP workstations in a variety of forms for every part of our business. So we work on commercial and mixed-use projects. We recently finished United Airlines headquarters in Chicago, as well as Tata Motors headquarters. We work on healthcare and science and technology. Among our peers, we're known as the leaders in healthcare. We work on academic facilities from high schools to universities and colleges, whether it be laboratories or classrooms or lecture rooms, or even sports fields. We become leaders in this field. And also, we are designers of public spaces and urban spaces. Those of you who've watched Vancouver Olympics, one of the main venues was the Richmond Oval, as you see on the top right. Another unique aspect of our office is the Yazdani studio. What Yazdani studio is, we're like a little design laboratory where we push the boundaries of design and try different things that hasn't been done in our industry. And sometimes we're known from our IT people as their worst nightmare because we tend to break stuff and we try things that weren't really meant for us. We question everything, whether the preconceived notion of a hospital or a building, whatever it may be. We say, what if we did this and what if we tried different things? And that's what we do as designers. We really try to push the boundaries. And this quick video shows you some of the processes involved. We go through a series of different analyses, ranging from sustainable functions. So we go through different iterations where we try different studies and to find the right and appropriate solutions for the project. Recently, we worked on a flexible armature project in which we took the idea of a flexibility in which skin can be readapted to different human body sizes. And it was featured in a fashion show where different models tried on different dresses, and it still maintained the same aesthetic appeal. With the success of the dress, we were asked to design a travel sack. And normally when you travel, you carry multiple bags, but with this sack, we were able to contract and expand to different needs of the project. So this level of exploration led us to work on a much larger scale project like the one you see up here. This is a project in Jeddah, Saudi Arabia, where it's a sports stadium where we took in various parameters such as sightlines, programs, different solar control, lights. All of that was scripted and put into an algorithm, as you see up there, and produced a result that went through several iterative process. The end result is what you see up here, which is a cultural motif in which we mutated and distorted to provide an interesting array of ideas. The end result is this stadium in its context, as it is shown in the images up there. At a much smaller level, we took the same idea of patterning using simple materials such as felt and articles of clothing for this exhibit at Museum of Tolerance for Anne Frank. And then for another project where we took the idea of flexibility and turned this curved glass wall that can be reconfigured to any size depending on the users and demonstration purposes. The project that I'm going to be talking in more detail about is called CJ Only One Research and Development Center. For those of you that don't know CJ is one of the largest conglomerates in Korea. They're the leaders in entertainment. They actually hold majority stake in DreamWorks. They're also leaders in food, biotech, and pharmaceuticals. We were asked by the client to create a large single complex in which the three of the divisions, biotech, healthcare, and food, to be located in one location. They all wanted them to move from different parts of the country to a single location in which creative collisions could occur. And the way we were able to achieve this was to create three different unique towers that were brought together by a single atrium with collaborative roof gardens and landscapes that tie them together and have a space in which they can have informal conversations, informal ideas, and whatnot. The building itself is all glass, but what we did to bring the three different groups together is to create this almost ephemeral veil-like structure that tied the buildings together. So that even though the building itself has its own unique identity, as a firm or as a company, it's envisioned as one single building. As I mentioned earlier, since our client is one of the leaders in the entertainment industry, the way this video was, the animation was made is something that we do as part of our in-process study. We do several of these for the clients, and a lot of times we present this in real time to our clients in workshops, seminars, and whatnot. And we rely on dependable, high-performance machines because we're showing these in real time, and decisions are being made on the fly. So this is the atrium that ties all the different departments together. They're all collaborating in these bulged spaces, which I will show you later. And the skin, unlike some of the other customers that we work with, we were fortunate to have this client who really pushed us in coming up with a very creative design. At one point, we even explored the idea of having a operable skin, and we tried different iterations and showed to them what you can do with this skin. And we were very successful with it, but in the end, the economics and the reality of trying to do an operable skin at this size, which is over 1 million square feet, didn't seem feasible. So as I mentioned earlier, the three towers, you can see that you have the biotech, food, and pharma. We never really intended it to look like the logo, but through the process, we were inspired by the logo. But at the same time, we had to rigorously test the idea of whether it was valid or not. And you can see on the bottom, we're looking at the skin being exposed to the solar elements and providing a skin that provided shade and performance to the building. Again, this is the inside view looking up the atrium. We took the same fluid movements that tie the building together to the inside and created these collaborative spaces and connecting spaces for creative collisions. The outside, when these creative collisions are occurring, the aperture of the facade actually opens up. So from the exterior, when you see these openings, that means there's a meeting room or conference room or some type of collaborative spaces are occurring. And when we look at it in more detail, the perforations that you see in the facade actually change depending on the orientation and sight lines. So if it's on the north facade, the perforation sizes change. And the result is to create this panoramic view without any mullions and have a clear sight of what they're doing, what they're seeing, and what to be inspired by. And the way we were able to achieve this was to create this special strong back system in the ceiling, and that allows us to span between the columns without any mullions and have a clear glass. So none of this would have been possible unless we had the tools like HP Workstation in our daily process. We've gone through several iterations, going from one workshop to the other, showing the different process and ways of showing this model. So in the result are these 4 mock-ups that were done recently. Having done a lot of the studies ahead of time and doing the tests, we're able to virtually mock up the entire thing digitally and test them out physically and how they get fit on the site. Unfortunately, unlike a digital world where everything fits in perfectly, what you don't see here is there's a guy behind that screen hammering things, because in real life, things never work out perfectly like my mic. And this is the final piece, the context. So I mentioned earlier about SIFMO, and since we have teams from Chicago who is focused on corporate identity, our team in San Francisco, which is focused on laboratory, and our New York office, LA office, Shanghai office, all working on this project, we have an enormous amount of data that needs to be shared among our team members in real time. Just to give you an idea, every one of those single panels that you see in this facade has been modeled, tagged, identified, so that we know at real time how much this thing costs, how is it assembled, where does it go, and whatnot. And not only that, it gets even more detailed because they get flattened out and shown how these pieces are going to be cut out, placed in order. And then we use programs like Inventor, which requires a lot of RAM and real-time hardware graphics for looking at every little detail of the facade and how every component comes together. And we make real decisions like this in workshops where we bring our workstations and show them what the consequences of certain design changes that occur in these workshops. Every armature that are attaching to the building is tested, looked at. We even build our own physical models to test how things come together so that we can share with our fabricators and contractors how things come together. So this is one module that gets put onto a building, but we took the same rigorous steps to show this in real time with our clients by a physical model. During one of the workshops, there was a question about the cost to actually cut and weld one of these outriggers, and the time that it cost them. They were saying, what if you were to plasma cut a single piece of steel that's about this thick? Normally that's not the right thing to do because of cost, but because of time and efficiency, we looked at it to see if it was even possible. And that's why we had to do these iterations in real time, both internally as well as with our clients. And here you see the final product. You can see the transition from digital model to physical reality is very seamless. And doing this as much as possible in the digital world lets us achieve to where we have today. This is the more recent photos of the building topped out. And this is the screen module that's fitted onto the building. And just to give you an idea of the size, this segment is about 65 feet long, curved in 2 directions. You have perforations that are going in a complex curve and weighs about 10,000 pounds. So this is about the weight of 2 SUVs hanging on the wall. We need over 600 of these pieces. On a daily basis, the fabricators will be creating 2 panels like this and shipped onto the site in the middle of the night and putting it up each day. So for 1 year, they're going to be putting this up. So we have to make sure that everything that goes up is done correctly. In addition to getting things done correctly, we've done tests, and this is a performance test in which we've done the test kind of digitally, going through different stresses and wind loads. But like I said, you had the guy hammering at the last minute. We have to test it to see if it actually works. And this was done recently and successfully, so we are very proud of the end result of this test. This is the atrium lobby, and this is the conceptual idea that ties to it. This is the atrium looking down, so those collaborative spaces, the bulges that you saw at the bottom, are these meeting points throughout the space. This is a roof garden that ties the different collaborative spaces together. Just below that, you have these collision spaces, lounges, meeting rooms. And inside the research lab, you have what we call the new science of workplace, in which we bring together collaborative spaces as part of the working environment. And then when you need some quiet time to think, these are placed around the building so that they can take a moment to breathe and come up with ideas. And also, when we have enclosed labs, we try to create these undulations to make it look less like a corridor, but more like a free-flowing space. So in conclusion, the way we explore, design, push the boundaries of design, using HP Workstation as part of our daily process, communicating, collaborating, and creating, lets us transition smoothly from a digital world seamlessly to the physical world without any conflicts and making it all possible. Thank you very much.